So on this one, you want to be careful right away. Remember how I was talking about domain. If I evaluate the limit as x approaches 6, and I were just to plug in, look what happens. 6 squared minus 36 over 6 minus 6. 6 squared is 36 minus 36 over 6 minus 6. 0 over 0. No good. No good at all. So that means that we have some sort of issue here with the limit as x approaches 6. So in previous topics, we would say, let's go from the left, let's go from the right, throw up a graph, see what's happening here, and then we'd be able to come up with a conclusion. What we could also do, though, is we can factor. Notice the top here, we have a difference of 2 squares. X squared minus 36 is a difference of 2 squares. X squared is a perfect square. 36 is a perfect square. So x minus 6 and x plus 6, just knowing difference of 2 squares formula there. So I would have x minus 6 limit as x approaches 6 times x plus 6 over x minus 6. And then what happens is the x minus 6 is canceled. So we have the limit as x approaches 6 of x plus 6. And then now I'd be able to just evaluate the limit. So the limit as x approaches 6 of x plus 6. Plug in 6, we get 6 plus 6, and that equals 12. And so you always want to check that domain when you first start. You want to make sure that the limit as x approaches some value doesn't cause any sort of issues with the domain, which in this case it did, because we have 0 in the denominator. We never want 0 in the denominator. So then that means we had to try to factor and then go from there. So this one factored nicely. Be able to simplify, x plus 6, game over, moving on. Now this is going to take a lot of different forms though. So you really have to know your factoring and know that simplifying process.